the nth root of a all to the power of m, which is what we did. So either one of these are okay. You could do a to the m first and then take the nth root, or you could do the nth root of a first and then to the power of m. So let's take a look at example 3. It says evaluate this. This is negative 8 to the power of 4/3. So I'm going to stick to what I originally did, and I'm going to take care of the third first. So this is the exact same as the third root of negative 8 all to the power of 4. Okay, because the third means the third root, and it's still all to the power of 4. So continuing this, the third root of negative 8 is negative 2, because negative 2 times negative 2 times negative 2 is negative 8, all to the power of 4. And negative 2 to the power of 4 is positive 16. So the answer to that one is positive 16. This one here, 9 to the power of 2.5. Well, 9 to the power of 2.5, we don't know how to deal with a decimal as an exponent, but we do know how to deal with fractions. Now 2.5 is the exact same as 5/2. Now if you cannot convert 2.5 into a fraction, the easiest way to convert a decimal into a fraction is write the decimal over 1. Then to get rid of the decimal, you multiply both top and bottom by 10. So this would be 25 over 10. And of course you can reduce this. Both are divisible by 5, so this is the same as 5 over 2. Okay, so you got to be able to convert a decimal into a fraction. Now that you have it as a fraction, now we can apply the same rule as we did over there. This is to the power of 1/2 means the square root of 9 and then still to the power of 5. And the square root of 9 is just 3, so this is 3 to the power of 5. And then you can, this is not too bad of a number, you can actually evaluate this one. 3 times 3 times 3 times 3 times 3, 5 times is 243, I believe. Yes, it is. So this is the final answer, 243. If it's 3 to the power of 7 or something like that, you can leave it as 3 to the power of 7. Now this one here is a little different. This one here, you have the base is 25 over 4, but you have a negative exponent. Remember what a negative exponent does. That's what I'm going to take care of first. The negative exponent flips this fraction upside down, so this, in order to get rid of the negative exponent, you have to rewrite this as 4 over 25 to the positive 3/2. Notice that I don't flip anything in terms of my exponent. It's just the negative just flips the base. So the negative makes this 4 over 25 to the power of 3/2. Continuing this, now you got to remember that the 3/2 applies to both top and bottom. So I will take care of the half first. So I will take care of the square root of both top and bottom and still leave the 3 out here. Continuing that, that's what the half does from the bottom, takes the square root. So then taking the square root of the top is just 2, taking the square root of the bottom is just 5, and still to the power of 3. And you have to also understand that that cube applies to both top and bottom of that fraction. So you'll have 2 cubed all over 5 cubed. 2 cubed is just 8, 2 times 2 times 2, and 5 cubed is 125. So that's your final answer there. Over here, example 4 says, simplify then evaluate. So I wouldn't try to get rid of these, fourth roots and square roots of 16 and all that. I wouldn't do that just yet, because if you understand exponent rules, remember what you learned in day 1. Day 1, you have, this is a 16, a base 16, and so is this. You're dividing two bases that are the exact same. When you divide two bases that are exactly the same, you keep the base and you subtract the exponents. So that's what I'm going to do. 16 to the power of a quarter times 16, divided by 16 to the power of 5/2. I'm going to keep the base as 16, and I will subtract the exponents in order. So 1/2 minus 5/2. Now, obviously, you're going to have to know how to subtract fractions. If you want to subtract this off to the side, that's more than fine. So if I do a quarter minus 5/2, How do I subtract these two? I have to come up with a common denominator. The common denominator here is 4. Okay, I can make this a 4 by multiplying by 2, so I have to do the same to the top. So 5/2 is the same as 10/4. 1/4 minus 10/4 is a total of 9/4. Negative 9/4, my fault. So that is the proper answer for when you subtract those exponents. So this is actually 16 to the power of negative 9 over 4. Now, when you get to this, now you're going to have to do some work here, because the first thing you're going to take care of is not the fourth root, but the negative. To get rid of the negative as your exponent, this is the same as 1 over 16 to the positive 9/4. And continuing this, now I will get rid of this stuff here. This is 1 over, now the quarter means the fourth root of 16, and then to the power of 9. And we know the fourth root of 16. This is just going to be 1 over 2 to the power of 9, because the fourth root of 16 is 2. 2 times 2 times 2 times 2 is 16. And if you'd like to leave this like this, you can leave it like that, because 2 to the power of 9, big number. Or if you have a calculator, you can do that and come up with, I don't think it's that big of a number, you can come up with 2 to the power of 9 if it's not too big. And then over here, if we take a look at this example, last example here, this is 27 to the power of that divided by all this stuff. Now if you notice, I'm not going to start getting rid of negatives as my exponents and start doing the third roots and all this stuff. What I'm going to attempt to do is use my exponent rules from yesterday. And from yesterday, it's asking me to do this inside here first, so that's what I'm going to do. I'm going to leave this as 27 to the negative 2 over 3, and then it's going to be divided by, and I'm going to figure out this answer in here. Now, that is two bases that are the same, and you're multiplying them together. Whenever you have that, two bases that are the same and you're multiplying, you keep the base the same, and you add the exponents. So negative 1/3 plus negative 4/3 is the same as negative 1/3 minus another 4/3, so that's negative 5/3. So I just just added the exponents, kept the base the same. Continuing this, now this is division between two bases that are exactly the same, and the rule for that is keep the base the same and subtract the exponents. So subtracting the exponents, I'm going to get negative 2/3 minus negative 5/3 for my exponent. So if I do that, this is 27 to the power of negative 2/3 minus a minus becomes a plus, so negative 2/3 plus 5/3 is positive 3/3. And then so this is just 27 to the power of 1. And that's my final answer. My final answer is just 27. I actually lucked out here because I don't have to do anything in order to get rid of negative exponents, third roots, or anything like that. And so this may occur when you're simplifying. So always try to simplify first using your exponent rules for multiplication division. And then at the very end, if you still have something that looks like this, then you can start simplifying the negatives and the fourth roots into the power of 9s. Otherwise, you may end up having a nice answer like this at the end.